Hello, once again, honors chemistry fans. Let's talk about dimensional analysis. What is dimensional analysis? It is a math process, is really what it is. And here's what I'm going to start out by saying. Absolutely, if you understand it, feel free to use dimensional analysis. I think it will aid you tremendously in understanding chemistry and being able to do calculations efficiently. But also know this everybody's math mind, how they see and interpret math is slightly different. So you do the math in the method that is correct that leads you to the correct answer. Okay. As we are getting to understand, and you're going to see a lot as we do our work in chemistry, we are at this level an algebra based um, science class, or a science class with a lot of algebra in it. We are also a science class that, while science works in metrics, not the rest of the God bless USA works in metric. They work in standard. Even within the metric system, sometimes we have to go from kilograms to grams or liters to milliliters, things along that line. But there's also times when we might have to go from pounds to grams or gallons to liters. One of the greatest ways to do that, and know, especially if you have to string a lot of math processes, math steps together, um, or I should say it this way: if there's a lot of math steps to do in a problem and it fits into the dimensional analysis mode, then you can spend more time on a setup. And that's really the key to dimensional analysis. You spend a little more time on a setup, because if you set up the problem properly, you can check before doing any math and know that you're going to get the answer correct unless you make an error on your calculator. Okay. It's also known as the factor label or picket fence method of converting units. And here's the key component. Units are our friends, really. This is the key now to doing math, where you're not just writing down the number, but the units that are with it: grams, milliliters, centimeters cubed, whatever it might be. Okay. So that picket fence is a method. Again, picket fence, dimensional analysis, factor label is a method to convert units like feet to inches, kilometers to meters, kilograms to grams. Why is it so important? Units constantly need to be converted throughout chemistry. And here's the relationship. The simple like conversions of standard measure to metric or metric to metric measure is the same exact process you do in stoichiometry. The one thing we are leading to, and the one key component of chemistry, is stoichiometry. It doesn't matter. After this class, you can go on to become a chemist or a chemical engineer. Every bit of chemistry you do will involve stoichiometry. When we get through stoichiometry, everything we do the rest of the year will involve stoichiometry. It is the key concept of chemistry, and it's the relationship between the reactants and the products, and you're determining how much you can create of one or the other. Okay. So if I know exactly how many reactants I started with in mass, I can figure out exactly the product mass I should produce, kind of thing. But it's the exact method you use in stoichiometry, so we learn it early with just simple unit conversions. Okay? It leads to understanding what equality is. And equality is ratios that equal to 1, right? This is, if you look at your cheat sheet right now, which I want you to do, look at the cardstock or the downloaded one for distance learners, that cheat sheet, that periodic table I gave you, flip over the periodic table and look on the back side of that. And on the right-hand side down the column, you will see all sorts of equalities. Like 1,000 grams equals a kilogram. 3.28 feet equals 1 meter. That kind of stuff. Anytime that you put two things that are equal to each other in a ratio, they equal 1. Okay? Because they're equal, they cancel each other out and they become a ratio of 1. Okay? Doesn't matter how I orient them. 1,000 grams per kilogram or 1 kilogram per 1,000 grams, they always equal 1 because they are the same thing, just different units. Okay. All right. 1 kilometer is 1,000 meters. And again, I can orient that equality anyway. 1,000 meters per 1 kilometer is the same as 1 kilometer per 1,000 meters. They are the same number in different units. They're equal to 1. I need that conversion factor, or what's called a conversion fraction, to change the number that I want to convert. So in these dimensional analysis problems, I'm going to have a number that I want to alter, change the units on. I need the equality with it. So I need the number and I need the equality. Or very possible, I may need multiple ones, which is why I'm saying if you have multiple steps, you can set it up all in one shot instead of doing the math, get the answer, then use that and get the next answer and so on and so forth. And which way do I orient it? It depends on what you're trying to do. So how does dimensional analysis work? It involves multiplying and dividing. In order to perform any conversion of units, you need a conversion factor or fraction, like we showed you, inequality. Something off of that table on the right side, on the other side of the periodic table, where it shows you volume, length, speed, things like that. So 1 inch is 2.5 centimeters, or 1 dozen is 12. Okay. Conversion factors are made from any two terms that describe the same or equivalent amounts. They're just written in different units. Okay. So conversion factors are nothing more than equalities or ratio that equal to each other. Math are equal to 1. 12 inches is a foot. I can write either 12 inches over 1 foot or 1 foot over 12 inches. Okay, and I'm trying to be intentionally redundant to drill this in your head. Conversion factors look a lot like fractions, but they are not fractions. They are ratios that equal 1. Because again, they're the same number, they're the same amount with different units attached. Critical thing to note is that the units behave like numbers do when you multiply fractions. That is, inches or feet on the top, inches or feet on the bottom. However, they cancel out just like in algebra. This is why the setup gets you to the right answer before you even do the math. So here's our rules. Write down the given number plus its unit. Draw horizontal and vertical lines. That's why they call it the picket fence. Enter the conversion factor with the proper orientation to cancel out the given number of units and only leave the units that you want. And then do the math. Okay. All right. Horizontal divide, vertical multiply. What do we mean? So here's an example. I want to change 25 kilometers to meters. Here's my conversion factor. 1,000 meters is 1 kilometer. Write down my number. Draw my picket fence. Orient this so that it's actually 1,000 meters over a kilometer, so these kilometers cancel. Okay. Here's my given, here's my conversion factor, here's what I want. 25 times 1,000. Hey, does that mean we have a typo back here? I think it means we have a typo. Yes, if you're going horizontally, you multiply. If you're going vertically, you divide. You know what? The magic of film, let's just watch this happen right now. Or spell it correctly. All right, let's get back to presentation mode. So that's what we did. 25 times 1,000 is 25,000 divided by 1. Okay. 25,000. I needed two significant figures. So I can write it this way, or I could certainly, and that's fine because it's 1, 2, and these are placeholders, or I could put it into scientific notation if I, you know. The key is when you're orienting these things, the one you want is on top, the one you want to get rid of is on the bottom. Kilometers cancel. Okay. Convert 12.5 grams to kilograms. Here's following the rules. Write down what I know. Draw my picket fence. My conversion factor is 1 kilograms 1,000 grams. Orient it properly so that grams are on the bottom and cancel. 12.5 times 1 is 12.5 divided by 1,000 is 0.0125. Don't forget to write the units. That's the key. I could set it up here and know that unless I made an error in the math, I was going to be right because I canceled out grams and only kilograms was left. And again, 3 significant digits, so it's 3. What about conversion factors? They are considered limitless because they're equal to 1. They are considered infinite, so you don't use conversion factors in your rounding to significant digits. You only use the number you start with. Okay? Funny joke, what happens without units? There you go. So, how many feet are in 60 inches? Solve using dimensional analysis. All dimensional analysis problems are set up the same way. They follow a pattern that follows our stoichiometry we learn later in the year. What units you have times the ratio, what you want over what you have, and then you do the math and you get the units that you want and the answer that you want. So that's the number and units you start with. That's the conversion factor. That's the units you want to end with in the answer when you do the math. Okay. Oops, I missed it. You need to convert something that will convert inches into feet. So 60 inches. So 12 inches is a foot. Written as an equality. It's 1 foot is 12 inches, or vice versa. 60 inches times 1 foot for every 12 inches. Inches cancel out. Okay. And it comes to 5 feet. 60 times 1 divided by 12. Okay. And this is another way, if I didn't draw the picket fence, I just took it and multiplied it by the conversion factor, which I knew would be 60 times 1/12 or 5. What you want, what you have, times the unit you want, gets you the units you want. Also, here's our picket fence. Whatever works best. This format more visually integrated, more bridge-like, and it's more appropriate for working with factors. In this format, the horizontal bar across means divide, and the vertical lines mean multiply. That's what I meant in the beginning. But I like to think of it this way. If I'm going left to right, I'm multiplying. If I'm going top to bottom, I'm dividing. Okay. So yes, the horizontal bar means divide, the vertical lines mean multiply. Try 18.2 kilometers to meters. And then how many centimeters are there in, 5.54 inches. Okay, so I'll leave those for you to practice. And again, certainly can ask me anytime to double check those answers. The hardest part about dimensional analysis is knowing which conversion factors to use. Some are obvious, like 12 inches in a foot. Others are not, like how many feet are in a mile. That's why we give you a list, a laundry list of things to help, but not everything in the world's on there. So some things you might have to think of, like how many pounds are in a ton. Okay. Significant digits never use the conversion factor. They are considered infinite because they are equalities that are equal to 1. So you need to put gas in a car. Let's assume that the gasoline costs $3.35 per gallon and you've got a $20 bill. How many gallons of gas can you get with that 20? Okay. Here's our picket fence. $20, $3.35 a gallon. I put the $3.35 on the bottom because the dollar signs will cancel out. Multiply 20 times 1 and then divide by 3.35. 5.97 gallons of gas is what I can get in there. I think gas is a little cheaper right now. What if you had wanted to know not how many gallons you could get, but how many miles you could drive, assuming your car gets 24 miles per gallon? Let's try building the previous problem. Okay. So you can try it. There you go. 5.97 gallons times 24 miles per gallon. You can get about 143 miles. Now, okay. Instead of chopping that up into two parts, you could have done that all in one. And that's the beauty of dimensional analysis. Multi-step problems, if they fit into dimensional analysis, you can all set up as one. Okay, so let's look at this problem again. I'm starting with my 20 gallons. Okay, I'm drawing my picket fence. I know initially I got to get rid of dollars and into gallons. So that's when I put 1 gallon is 335. But then I want those gallons into miles and 24 miles per gallon. I've just done it all in one fell swoop. I haven't even done the math yet, but I can look and see that everything cancels by miles. So I do 20 times 1 times 24, divide by 335 times 1. There you go. $143 miles. Tallest building in the world stands 160 stories. The story is 18 feet. How high is that in nanometers? Okay, 160 stories. There's 18 feet per story. I've got nano stories in the feet. 1 meter is 3.28 feet. That'll get me into meters. And 1 meter is 10 to the 9th nanometers. Okay, so this is not the picket fence. The picket fence would go here and here and here. Okay. And it comes out to be 8.9 times 10 to the 11th nanometers. Okay. There you go, dimensional analysis in a nutshell. And that will allow you to really finish most of the rest of your unit outline. Again, if you have any questions, keep checking in at class and during office hours. Have a great day.
Hey, Tom.